This is going to be a new unit where we're going to mainly focus on right triangles. And whenever we're working with right triangles, we're going to use Pythagorean theorem, which leads us to using the square root, okay, also known as a radical, okay? So we're going to, this first lesson, we're going to learn how to simplify radicals. So let's do a little bit of vocabulary. When we say radical, all that simply means is that it's basically just a square root, okay? And it also can be used as a cube root, a fourth root, and so forth, but we're going to just mainly use the square root, okay? Radicand. A radicand is going to be the term or terms under the radical. So for example, if you say, let's see, square root of, I don't know, 2x, the radicand is 2x, okay? And then the coefficient, you guys are familiar with that from algebra. It's the term or terms out in front of the radical, okay? So if we had, say, 4 radical 2x, the coefficient is 4 and the radicand is 2x, okay? So that would be the coefficient. Over here underneath the radical is the radicand. So if you just hear us use those terms, you got to know what we're talking about. Okay, so this is not a necessary thing to know, but it's always good to have the perfect squares table and the numbers kind of fresh in your head whenever you're simplifying radicals. So I'm going to go ahead and we're going to write down the perfect squares for all of these. And so for 1, the perfect square is just 1 because 1 times 1 is 1. And then the perfect square for 2 would be 4. Okay, and we say that it's a perfect square because when we take the square root or radical 4, it takes us to 2. Okay, so this one would be 9, this one would be 16, 25. All of these you guys mostly know. 81, 100. Now here's where we might start to, and even myself, not know all of these entirely. So I'm going to use my calculator on some of these. And so again, when I take the square root of 196, I get 14. Okay, and that's why we call it a perfect square. 16 squared, this would be 256. 17 squared is 289. 18 squared is 324. 19 squared is 361, and 20 squared is 400. Okay, so you don't have to have these memorized. Again, it's just always kind of good to have these kind of fresh in your head whenever you're simplifying radicals. Okay, so you're going to see these pop up. All right, so how do you simplify radicals? I know you did a little bit of this in middle school, okay, or in algebra, I should say. And so there's 2 ways that you can do this. This first way that I'm going to do is simplify out the radical, but using perfect squares, okay? So when you say that, you want to factor out the greatest perfect square possible. And if a number does not have a perfect square, that can be factored out, and then you'll just have to leave that in the radical, okay? And then be sure that the radicand is not a fraction, and then also be sure that there's not a radical in the denominator of a fraction. Okay, so with this right here, the greatest perfect square, and again, if you go back to this list, which one of these blue numbers, meaning the greatest one, will divide into 32 evenly, okay? And a lot of kids will end up saying, oh, 25, because that would be the largest. No, that 25 does not go dividing into 32 evenly. So that you'd have to go a little bit lower over here. And so 16, I believe, would be it. So 16 times 2. And then you kind of just continue with that tree. So 4 times 4. So now all we have to do is just realize that pair right here is going to go out in front of the radical as our coefficient, and then this right here, whatever's left over, is going to go back as a radicand. Okay, so the simplified version of radical 32 is 4 radical 2. Okay, I'm going to box my answer right there. Okay, so that's one way, and you can see this little tree right here is very small. Now over here, on this one, we're not going to think too much. We're just going to expand it and think of 2 multiples. So a lot of people will probably say, oh, I know, 8 times 4. And you're just going to, and then this is 4 times 2, and this is 2 times 2, and then that one is 2 times 2. So you just want to expand it all the way through, okay, until you can't anymore. And now you want to use where you circle every pair of numbers out, okay? So we have this one, we have this one, and then we have this one left over, okay? So this is like a 2 that is going to come out in front, and then so is this 2 right here. And then we have 1 left over, and I like to say to underline whatever is not circled, because when you underline, it kind of goes with putting it back under the radical, okay? So you see this 2 went right here, this 2 went right there, okay? You want to simplify that one more time. 2 times 2 is 4 radical 2. And then that would be my simplified answer, just like I got over here. So you can see the difference here in both ways to simplify radicals. This tree is much larger, okay, but not a lot of thought process. This one is a much smaller, but we had to think a little bit on how to use the greatest perfect square. So it really doesn't matter which way you use, because both gets you the same answer, okay? One just requires a little bit more writing. All right, do I have any examples down here? No. Okay, so let's go on and try it again. This time it has a coefficient. So all it says that you're going to use the same steps to simplify it, and then at the end you'll have to simplify it by multiplying this radical. So let's see. So I'm going to simplify this 54, and keep in mind we have this 5 out in front, and we'll just kind of like drop it down and remember that we have that. So the 2 numbers that I can think of is 6 times 9. Is that right? Yes. And the 9 I know is a perfect square, so I'm going to underline that, circle that, and that's going to come out and join the 5 out here. The 6 you can simplify more, but you get 3 times 2, and you're not going to really get anywhere, so you can actually stop right there and underline that. So if the 3 is going to come out and join this 5, so we basically have a 5 and a 3 out in front, and then we have a 6 under the radical, which is just simply 15 radical 6. Okay, so that's simplifying with a coefficient on in front. So there's a couple of examples here that I want to do. So let's try this one here. A little bit larger number, so we probably need to think a little bit more. So when I look at this 300, I want to think of 2 numbers that multiply. And I like to do the biggest perfect square that will divide into that. So a lot of people will probably think, oh, do 30 times 10. That is true, and you can do that. But I know that 100 times 3 is equal to 300, and I know that 100 is a perfect square, which is 10 times 10. And then I can just underline that. So I like using the perfect squares just because it's a little bit less to write. So this 10 is going to come out and join the negative 14. So it's going to be negative 140 as the coefficient, radical 3. And that is my answer for this one. Okay, let's try this one over here, 192. So that one's kind of a weird number. So I'm going to actually use my calculator and see. And I'm going to go back and refer to this table right here and start thinking maybe one of these numbers over here can divide into 192. So 192 divided by 36. Nope, it does not go into evenly. 192 maybe divided by 49. 49 is a perfect square. Does not. 192 divided by 64. Aha, 64 goes into 192 evenly, okay? And it's not always the case. Sometimes they don't at all. So 64 times 3. I know 64 is a perfect square because it's 8 times 8, and then I'm going to underline that 3. So I have the 8 that's going to go out and join the 9. So I'm going to end up getting 72 as a coefficient. And then 3 is going to go under the radical. And that is the simplified answer for that one. All right, pretty easy. So now let's move on to simplifying radicals with variables now. Okay, so you're going to pretty much do the same thing. The only new part right here is we're going to take the step and expand the variables, okay? And then you're going to end up pairing them up and doing the same process as you would with the numbers as far as pairs, okay? So let's look at this one right here. So I'm going to do the number the same way that I just did, 72. I know 36 goes into 72 twice. And I like using 36 because that's a perfect square, 6 times 6. Then I'm going to underline the 2. So the 6 is going to go out in front as a coefficient, and the 2 is going to go back under the radical. So now let's work with the variables. So it says g to the 4th. So it said expand the variables. G to the 4th means g times g times g times g. Okay? And you learned that in Algebra 1. So we're going to do the same thing with h. H to the 3rd is h times h times h. Okay, so now we're going to circle the pairs. So I have 1 here and 1 here, 1 here, and then I'm going to underline that h. Okay, so I also have this pair right here, and then I have that 2 underlined. So everything that's underlined is going to go under the radical, and everything that is circled is going to go out in front as a coefficient. So my final answer is going to look something like this. 6 will be first. I have 2 g's going out, okay? So g times g. So instead of writing g, I'm going to write g squared. And then I have 1 h going out in front. So there's my coefficient. So now my radical comes into play, and I have a 2 and an h that is underlined. So 2h will be my radicand. And that's my final answer. So that's what this is simplified. So let's try some more examples with more variables and different numbers, okay? Now something to think about that also. I'm gonna have to get my highlighter so you can kind of see this. So under the radical was g to the 4th. Outside of the radical was g squared, okay? And so if you think about it, g to the 4th is basically, if I take half of the 4, that's what got me the 2. So let me show you where that comes from, okay? And some of you guys may want to do this in your head. So if I have a radical, okay, so g to the 4th, and I have a radical over it, the exponent of a radical is 1/2, like this. So this right here with a radical means the same thing as this with an exponent. Okay, so radical g to the 4th is the same thing as saying g to the 4th raised to the 1/2. Well, you learned in Algebra 1 what you do to a power raised to another power, you multiply those. So what is half of 4 when you multiply those two? The 2 that we got over here. Okay, now the 3 is a little bit different. Half of 3 is 1.5. Okay, we'll see our 1h came out, but we still had a half, which needs to go under the radical. Okay, so you can kind of do it that way also. But if it's kind of hard to understand, then you just want to simply expand the variables, which is a very easy concept. Okay, so let's try these 2 examples with variables. So I have negative 9a, 60, a to the 6th, b to the 5th. So I'm going to reduce the 60. So some numbers that come to my head would be 4. I know 4 goes into that. So 4 goes into it how many times? 1, 15. And then 4 is 2 times 2. I got me a pair. 15 is 3 and 5, but that's not going to get me anywhere. So I'm going to stop right there and underline that 15. Okay, so now the a. What is half of 6? Remember, half of 6 is a to the 3rd. So a to the 3rd is actually going to come out over here. Okay, now this is an odd number. So what's half of 5? 2.5. So there's going to be 1 left over. Okay, so now let me show you the little bit longer way. A times A times A and A. Right? And so now watch when I circle them. 1, 2, 3. 3 pairs came out. Isn't that what I wrote over here? It sure was. Let's try the 5. B to the 5. 1, 2, 3, 4, 5. And let's circle the pairs. 1, 2, and that one's being underlined. Okay. Oh, I wrote a B earlier. I meant to write A. So let me go back and fix that because I had already did the A's. All right, and so you can see I have 2 B's that came out and I wrote A again over there. I don't know why I'm stuck on A. That should have been a B. So B squared, because I have 2 of those that came out, and I had 1 left over, which is why I put it right there. Okay, so it doesn't matter which way you do that. You can take half of the exponent and reduce it that way, or you can expand it all the way through and do it this way. Again, this way down here is a way easy concept to use. Okay, so now I gotta, round everything up and make sure I write my coefficient correctly. So I have a -9 out in front, and you may want to write it out first, okay? And then you can multiply later. So I have a -9 that's going to be out. I have this 2 that is going to come out in front. I have A to the 3rd, but then remember, guys, I have an A over here also. So what is that going to become? A to the 3rd, and A is A to the 4th. And then I have B squared. And then I still have something left in my radical. I have this 15 because that's underlined, and the B is underlined. So 15B. Okay, so now let's simplify it one more time. Move this over here. So I'm going to simplify it one more time. Let's write our final answer in green. I have -18 because that's what 9 times 2 is. A to the 4th, B squared, radical 15B. This is this simplified version of this one right here. Okay. All right, let's try it one more time. Again, with more variables, a little bit bigger exponents. And let's see how we do with that. Now, they wrote this a little bit out of order, and that's okay. Okay, so that's like -x squared 8y cubed. You can actually put that 8 out in front. Okay, so we'll deal with that here in a second. So let's start simplifying this radical 92. So 92, what goes into 92? So here's where you want to, use your calculator sometimes. Obviously, it's an even number, so I could divide by 2 and go from there. Okay, so let's just do that. So it's 2 times 46, and then I know 2 goes into 46 23 times, and 23 I'm pretty sure is a prime number, so we can stop there. So look, I have a pair here, and then I have that's going to be underlined. Okay, so this is going to go back under the radical, and then the 2 is going to come out and join that -8. Okay, what about the variables? So I have that x to the 7th. So again, what's half of 7? 3.5. So x to the 3 is going to come over here, but then I'm going to have an x that's underlined because that's the half. Okay, again, if you do not understand that, look what I can do easily. 1, 2, 3, 4, 5, 6, 7. Circle, 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 underline. So do you see how 3 x's are going to come out here and join my exponent? And then I have 1 left over, just like I said. So again, half of 7 is 3.5. Okay, I have a y, that's going to stay under, okay, because I can't expand that anymore. And then I have z to the 10th. What's half of 10, y'all? Half of 10 is 5. So a z to the 5th is going to come out in front. Okay, and so if you don't understand that, look what you can do. You can write out z, which I'm not sure is good. You want to do 1, 2, 3, 4, 5, 8, 9, 10. Circle, 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 and circle. You see how 5 z's came out in front? Okay, so you can either take half of it or expand it. Whatever's easier for you. Okay, so now let's simplify it one last time. Let's see what I'm bringing out in the front. So remember I had that -8 on in front. What's joining the 8 is that 2, okay? And you guys can do this step and you can simplify it, multiply it in your head if you want to. And then I have x squared and x to the 3rd. So you all should know that you add the exponents, so that becomes x to the 5th. I have y to the 3rd, and I have z to the 5th. And now comes my radical. What do I have underlined? I have a 23 underlined right here. I have an x underlined. I have a y, and that's it. Okay, so my final answer that I want to write down is -16 x to the 5th, y to the 3rd, z to the 5th, radical 23 xy. So that's my final answer with variables. Okay. I think that was the last example. It sure was. Let me make sure there's not one under there. Okay, and that is simplifying radicals with and without variables.